let's do this. At time t seconds, the acceleration a of a particle is given by the formula. Alright, we're good, lads? Alright. The acceleration a of particle p is given by a equals at plus 4. At t equals 0, p passes through a fixed point with a velocity of minus 24 meters per second squared. Show that p changes its direction of motion only once in the subsequent motion. Okay. It wants v. I need an equation for v. What is acceleration? dv dt, the change in velocity and the change in time. So I have dv dt equals at plus 4. Right. Dv equals at plus 4 to t. Alright, let's talk limits here. At t equals 0, what's the deal? Minus 24, and that's v, and that's t. Right, integrate. And here's what happens when we integrate. We're going to get a v from v to minus 24. And we're going to get a 4t squared plus 4t from t to 0. And we're going to get v minus 24 equals 4t squared plus 4t. And then v equals 4t squared plus 4t minus 24. I was looking at that going, that doesn't make sense. Minus 24 gives me a plus 24, and that's minus 24 there. You alright with that? Alrighty. Now, when is the velocity 0? Could you tell me? Right. So if I was to draw this function now, let's do it this way, right? So the question is, show that it changes its motion only, direction of its motion only once. If I threw this into the table function of the calculator, it will sort of map out its velocities for different times, okay? Now, minus times don't count, but for argument's sake, I'll go from minus 10 to plus 10. I should really start at 0, but I just want to show you what's going on. Minus 10 to plus 10, step of 1. Alright, has a positive velocity. It's currently decelerating. And it hits 0 at minus 3. Minus 3 doesn't count because there's no such thing as negative time. Keep going. Starts at minus 24 and it stays, it hits 0 to 0. Okay? Then it goes up to positive 24. So what does that mean? It changes direction once. It went from minus 16 to 0 back up to plus 24. And it's going to stay increasing for the rest of it now. So it means it changes its direction only once. You're basically looking for turning points. Is that okay? So you're looking for a turning point. So, not necessarily turning point. You're looking for when the v value equals 0. V value equals 0. Divide both sides by 4. 6. Solve. Look, I was going to write down the answer. It's t equals minus 3 and t equals 2. Which one doesn't count? So this means it changes direction only once because you can only count the 2. So it goes minus 16 to 0, then changes direction back up to plus 24. You alright? Tricky question. Find the distance travelled between t equals 0 and t equals 3. Alright, no bother. t0, t3. Alright, let's start off with this formula here. What can I replace v with? Anybody? Or dx dt, whichever one you want to choose. Okay, and cross multiply and integrate. And what do we get then, lads? So what we're looking for starts at 0, starts at 0. Oh wait, I'm wrong actually. Oh, 0 and 3, no, I'm right. 3 on top and x on top, and then it's going to be x from x to 0 equals, integrate that, and we get a 4 over 3t cubed plus 2t squared minus 24 t, all from 3 to 0. Sub in the 3, and what do we get? Anybody sub in the 3? Minus 18. Yeah. What does that mean? It's behind where it started. Yeah. It's if we look at our numbers again, you sort of go, if you look at your starting point, and that's your starting point, yeah? At the very beginning you're going minus 24, and then, oh, for God's sake, sorry, I'll hold this one, right, you're going left, alright, and what happens after 2 seconds, or is it 3 seconds? After 2 seconds you stop, and then you start going backwards, but you haven't gone far enough backwards to get back to your original point, so your x value is a minus 18, 18 to the left. Is that alright? Alright, all good. Sir? Yes. So lads, this gives the displacement from the original position. So imagine if you went, if you started off at this point here, you went 30 meters to the left, 10 meters to your right. The distance you covered is 40, but your displacement is, or minus 20 because you're 20 to the left. So this means doing 3 to 0 was not a good choice. So what did we need to do? We need to go back, and the table function is quite handy for this. We should have done 0 to 2, and then 2 to 3. The two changes separately. Okay, so we'll just change that to a 2. Change this to a 2. And what did you get there then, Mick? Minus 29.33. 29.33? Minus 29.34. Yeah. It's 29.33 to the left. So minus 29.33. But because we're doing distance, it's technically plus. Alright? Then we're going to go back, and this time we're going to do 3 and 2. Because we want to know how long did that take. Alright? So the limits this time are 3 and 2. And what did you get this time? Anybody? 11.33. 11.33. Add them both together. 40.66 is your total distance covered. And if you add the two of them together, they result in your minus 18 to the left, don't they? You go 29.33 to the left, but then you go right 11.33, which is 18 meters to the left of where you began. So we just answered the wrong question at the beginning. Good spot, Killian. Good job. Alright, now let's begin. A particle is moving along a straight line in such a way its acceleration is always directed towards fixed point 0. So, for those of you that don't do physics, it's something like this. Imagine the red dot is the fixed point 0, and you're always accelerated towards it. So, at this moment, the blue particle starts at rest. Now, what happens when it starts to move? It gets accelerated towards the red one. The acceleration is proportional to how much distance is between them. So at the very beginning, the blue and the red particle are the greatest distance apart. Everybody agree with that? So the acceleration is decreasing, but still moving towards the centre. What's the acceleration at this point? 0. But your velocity takes you out the other side. But what's happening now? You're actually getting decelerated, aren't you? You stop, then you get dragged back in. And that's what's called simple harmonic motion. You just keep going back and forth, back and forth. Is that alright? Now, it's given to you by this general equation here, where acceleration equals minus omega squared x. Omega is that w, curly w you're looking at there. Okay? So you'll be very familiar with this equation here. In fact, they didn't even need to give you that. They could have just gave you a is minus omega squared x, and you would have had to fill in v times the v dx. Okay? Now let's begin. So it's going to be v times the v dx equals minus omega squared x. We're going to rearrange this such that we're going to get omega squared x dx on the left and v to v, sorry, on the right, and v to v on the left. Next we're going to do some limits. Or can we do limits? The displacement from O at time t is x. So what does that mean? X and? Ooh. Just give me a second. Huh? Can't do limits. Yeah, that's what I'm thinking. Alright, let me read it. Okay. I reckon that's v and that's x. Okay. And then there we go. Rest at p. Which one's p again? A distance a from O. Partial steps from rest. From rest would mean 0. Distance a from O, that'd mean a. Is that what you got, Connor? Yeah. There you go. So you can do limits. They don't, but I like limits. So limits are quicker, aren't they? Generally faster and more efficient. V squared over 2, v to 0, and then minus, that's a constant, isn't it? So minus omega squared, and then x squared all over 2, and this is x and a. Good so far? Alright, let's keep going. What's next then? V squared over 2. Sub it in. Minus omega squared x squared all over 2. And then what about the next one? Double minus, so it's going to be plus omega squared a squared all over 2. What happens to the 2's? Cancel. And then we're going to get omega squared a squared minus x squared. Square root both sides to isolate the v. What do we get? U over. Sorry, square root, isn't it? Alright, good. And that's the two variations of the answer in your marking scheme, okay? Now what does it want from me next? I've successfully expressed v in terms of a, omega and x. The next one is I need to express x in terms of a, omega and t. Okay, what can I replace v with? dx dt. Now, which one do you use? The minus or the plus? Doesn't matter, does it?
Like, you can't tell that way, so in the end it doesn't matter.
Yeah, you could do, as I said, similar to what I did last question. Just pick one of them and go with it, and then just do just say if it was a minus, just alter the answer at the very end and compare both answers. Do not spend all day thinking which one is it. There's no point. All right. So Okay, so I'm going to go for omega. Yeah, I'm definitely. It's going to have to be some form of rule because we can't integrate that. So it's going to be the sine inverse rule, isn't it? And omega dt, yeah. And then what about over here then? What are our limits? Anybody? So do we start off? What's our distance at the beginning? That's a, is it? And this is? That's t, and this one is x. All right, let's keep going. Do we get sine inverse x over a? From x to a, and this is going to be omega t. Oh, sorry, omega to the power of t0, which is omega t. All right, we're going to get sine inverse. We're going to have sine inverse x over a, and then we're going to have minus sine inverse a over a, which is sine inverse 1. What is sine inverse 1? Simple harmonic motion only accepts radians, never degrees. So you would know this on the day of the exam. And then finally, what happens here then? Sine inverse x over a equals wt plus pi over 2, yeah? And then x over a equals sine omega t plus pi over 2. And then x equals, and this is your final answer, is it?
No.
Not your final answer. It's part of the answer though, is it?
Yeah.
Grand. Alright, how far along am I?
Good bit.
I'm here. Alright, done. Now, what does it want from me then?
Basically, sine pi over 2 plus something is the same as cos. That's something.
Oh,
That's what I wanted in that form. And that's why.
did you want it in cos or sine form?
They want it in cos form, and that's why it doesn't matter if it's positive or negative, because like with cos, you're going to get the same answer either way.
Yeah, alright, let's do that now. To be honest, they didn't specify, so it meets the criteria of the answer, doesn't it? But let's experiment with the other way. It does meet the criteria you've been asked for, so you wouldn't know to go any further. But let's experiment with that anyway. So what we're saying is that's sine an angle plus 90, isn't it? So what we're experimenting in is with what sine 90 plus any given angle is the same as what?
Cos.
Oh, you can use the are we using the a plus b rule? What's sine a plus b rule? Can you read it up again in your page 14? Go for it.
Sine A cos B plus cos A sin B.
Sine a
Cos B
plus.
cos A sin B.
I think that's what they might do here.
Yeah.
All right. The omega t is a. Omega t, and that's pi over 2. So that's omega t, that's pi over 2. That's omega t, and that's, sorry, just had to get rid of that. Yeah, I know. You don't even have to do this in my opinion, but look, we'll work with it. Pi over 2. But everybody agree that sine 90 is 0? Right? Do we end up back where we started from then?
It's not just end up in 2.
What?
That's not just end up.
Oh, sine 90 is 1. So it just ends up as cos wt, doesn't it? And then what Connor said earlier, you can just change that to. Do you know what that is? You've all done trigonometry, haven't you? And you're going to be very familiar with this very soon. Do you know the way cos starts up at its amplitude and does that?
Yeah.
And do you know the way sine starts off down here and comes up like that?
Yeah.
They're sort of like almost like what's it? Are they 90 degrees out of phase with each other? Is that what it is? 90 degrees out of phase. No, it's not 90 degrees. It's one sec. Just gonna verify what I'm thinking. Angle in unit. I'm gonna put in degrees. If my theory is correct, sine x plus 90 is the same as cos x, and they should both be in the same. They should both be in the same phase as each other. Let's find out. Yeah, sine and cosine are 90 degrees out of phase with each other. So they're both the same when you put them into the table function. So they are actually 90 degrees out of phase. That's what that's basically saying. Alright guys, obviously